Have you ever wondered why Linux powers everything from smartphone to satellites? Part 1 of our Linux basic series, we will explore how Linux started, kernel types, and core features. What actually kernel does and why it's so ideal for embedded systems. Linux is more than just a desktop operating system, it's an open platform, a toolchain engine, and heart of many embedded products. For embedded engineers like you, knowing Linux isn't optional, it's a core skill. Linux is not an operating system, it's a kernel, and Linux distributions are operating systems. Since Linux is a kernel, let's understand what kernel does. Kernel manages hardware, memory, processes, and devices. Kernel is the intermediate layer between application and hardware. We have five types of kernels: monolithic, micro, hybrid, nano, exokernels. In monolithic kernel, in kernel space, all services IPC, VFS, virtual memory, scheduler, device drivers lives in same memory address space. Advantages of it: faster in communication within the internal services and with the application. Disadvantage: if any of kernel space service crashes, it makes complete system bring down. Whereas in microkernel, lesser hardware abstraction available compared to monolithic kernel, and user space, device drivers, IPC, file servers has been implemented. Advantages of microkernel is if any of user space service crashes, entire system will not go down. Disadvantages of microkernel is slower in communication because the kernel is divided into kernel space and user space. Another disadvantage is along with the kernel, user space also key services has to be implemented. It is a bottleneck for the developers to implement for each and every architecture. Coming to the hybrid kernel is a combination of monolithic microkernel to achieve a balance between performance and modularity. It runs essential service in the kernel space for speed like monolithic kernel but moves same components to user space to improve stability similar to microkernel. Windows uses NT kernel, Mac uses XNU kernel. Nano kernel has even lesser hardware abstraction layer compared to microkernel. Exokernel application directly access the hardware. Coming to the performance, monolithic kernel equivalence performance to exokernel. Hybrid kernel is a little lesser than the monolithic, and microkernel performance even lesser than hybrid, and nano is even lesser than micro. So that's what monolithic kernel is preferred, which is a nothing but Linux kernel. Let's see the Linux history. AT&T developed Unix operating system in 1971 due to historic government antitrust regulations effectively prevented AT&T from commercially selling Unix as a product for many years. Due to these restrictions, AT&T couldn't profit from selling Unix as a commercial product. Instead, it licensed the source code to universities and research institutions, which led its widespread adoption and modification in academic circles. BSD stands for Berkeley Software Distribution. It's a Unix variant developed at the University of California, Berkeley, starting in late 90s. It has BSD license, which anyone can modify, redistribute. It's a unlike copyleft license, which means the source code no need to be released after commercialization. BSD still had Unix intellectual property source code in BSD. Later version of pre-BSD, they completely removed Unix intellectual property proprietary source code from the BSD. Then they name it as a free BSD. Coming to the Richard Stallman, he's an American free software movement activities and programmer. He campaigns for software to be distributed in such a manner that its users have the freedom to use, study, distribute, and modify that software. Software which ensures these freedom is termed as free software. He started the free started movement and he wrote GNU operating system and released in 1980. Since we have FreeBSD, you may have doubt that why again he had wrote from the scratch GNU operating system, because GNU free of BSD follows the BSD license, which means no copy left. There is no guarantee that user will get a source code. Since he didn't like that idea, he started GNU operating systems that follows completely free GPL licensed source code adheres copyleft. You can modify, redistribute, commercialize it, but should be copyleft with. Coming to the, let's understand a little bit about GNU. GNU uses the kernel, which is a microkernel. Since we know the microkernel disadvantage is the kernel lives in two spaces. One is the user space and kernel space. Due to that, we saw that disadvantages are slower in performance. Another thing is slower in adaptability because complexity comes in user space to implement the kernel services as well. So that's what initial days in 1980 GNU project is not so popular and adaptation rate is slower due to the hard microkernel. Then later we'll see how GNU become popular, what Linux contributed towards the GNU. Meanwhile, we have to understand in between what was happened, what is the key role of Andrew in life of Linus. In 1987, Andrew S. Tannenbaum is an American-born Dutch computer scientist and retired professor. He has launched Minix operating system in 1987. Minix stands for minimum version of Unix, Unix-like operating system, and also wrote a book, Operating System Design and Implementation, published in 1987. Again, he wrote a Minix operating system for the student to understand the code. It for research and student purpose. It's under BSD license. That means this is also not free, no copyleft. It's unlike copyleft license. Linus Torvald. Full name Linus Benedict Torvald is a Finnish and American software engineer who is the creator and lead developer of Linux kernel. Linus inspired from the book written by Andrew S. Tannenbaum, which is operating system design and implementation. Linus started working on Minix source code initially. Later, he feels GNU has more readily available operating system except its kernel. So Linus had wrote his own kernel for the PC he had at home and released the Linux in 1991 0.01 version. Later, GNU replaced from hard kernel to the Linux kernel and GNU under the GNU public license. GNU public license strongly adheres a concept called copyleft. Richard Stallman had implemented uses all user space program and system tools and utilities and hard kernel. Since hard kernel is microkernel, the adaptation of complete GNU operating system becoming much slower. Then later they replaced hard kernel with the Linux kernel. After 1991 Linux 0.01 version release, the GNU project will become famous and its adaptation rate has been increased significantly. Then today we are able to see the many Linux distribution. Here are the few Linux distribution I have shown. Here we'll see Ubuntu, Fedora, SUSE are mostly used for desktop. CentOS meant for security, so it is used more secure critical domains like banking and servers. Debian is highly used for desktop and servers. Red Hat is commercially being used for desktop and servers, whereas come to Android, it is mostly using in mobiles. Let's see few of the Linux kernel features. Portability runs on most of the architectures. We have architectures like x86, ARM, and RISC. So scalability, it can run a small tiny device which is having 4 MB of RAM, again a supercomputer which have 250 GB of RAM, for example. Compliance to standard. POSIX stand for Portable Operating System Interface. That means if any kernel is POSIX compliance, other kernel application which POSIX standards capable of running on this kernel. So we can run Unix application into Linux because Unix also POSIX compliance and Linux also POSIX compliance. Exhaustive networking, we have full networking stack available inside the kernel. Security, since the source is open, the review process is very strict, there is no loopholes missing any any flaws. Stability and reliability, Linux is known for it. That's what all the servers up and running with Linux 24 by 7 365 days. Again, it have one more feature, modularity, can include only what system needs even at runtime, which means any kernel module wanted to update while the server is on, we can just make that kernel service down and bring back, unload from the kernel and update it and reload back to the kernel with even without rebooting it. Easy to program, you can learn from existing code. Many useful resources on the internet is available. So that's for today. We will see the installation of Debian operating system, and we will gonna learn and few of the Linux commands tomorrow session. Until then, bye.